Okay, lesson 6.5, comparing properties of linear functions. Now, typically I do the student edition and work through, but for this particular case, just for time's sake, I'm going to use the teacher edition and just kind of talk about what they've done here. So here we have two different plumbing companies that we are comparing, Dan's Plumbing and Kim's Plumbing, having different ways of charging their customers. DT equals 35T represents the total amount that Dan's Plumbing charges. So what does that mean? He charges $35 per whatever T is. In this case, I'm assuming hours, but we'll look at it. Kim's Plumbing charges $35 per hour plus a $40 flat rate fee. Okay. So Kim's would be 35T plus 40. So 35 for the per hour, your rate, your slope, plus 40, the flat rate fee. So obviously you know that Kim charges more than Dan because she charges that extra $40. But how does this compare? Well, if we go back to the previous lesson, that plus 40 is a vertical translation up. That means our starting point is different. So you can put each of the functions in the calculator, y1, y2, look at your table, and you get a table of values here. This would be your x, this would be your y. And you can compare them and see what's different. Well, obviously the starting value is different, but then these all differ. By how much? Well, they differ by 40. Why? Because Kim charges that extra $40. So what does this do? Well, it affects the domain and range. The domain, well, sorry, it does affect the range, not the domain. The domain is your t, your time. Well, you can have the same amount of time. You can't have negatives here, so how would you denote your domain? Well, if you were going to write this down for domain, then you would write something like domain is either, you wouldn't say all reals, because if you said all reals, then you're saying, okay, that's positives and negatives and decimals and fractions and all that. Well, you can't have negatives here. So for domain, you're going to say x is what? Greater than or equal to 0, because it's got to be 0, but you also pay per dollar or per hour, not half hour or decimals. So if you said this, then you're saying all fractions and decimals. So that wouldn't work either. So when you're going through this, you need to think about it's got to fit what we're just doing in the context of this problem. So you would say x is what? Greater than or equal to 0 for all what? Whole numbers. So then you're saying 0, 1, 2, 3, so forth, so on. Or you could even just use this notation and remember to put your dots here to show that it keeps going on. Now that's going to be the same for both. What happens when you do the range? Okay, now it changes for each. For Dan, so for D of T, my range would be what? Y is greater than or equal to what? Well, Dan starts at 0. But what's it go by? It goes by 35. So you would say 0 for every multiple of 35. Now, that's kind of hard to do. So is there a different way to write it? Well, sure. Just like what we did for the domain. You could write 0, 35, comma didn't show, 70, 105, dot, dot, dot. So it keeps going. Now, what about Kim's? So for Kim's, K of T, her range is different. Why? Because her range starts at 40. So again, you could go 40 and then go 75, 110, dot, dot, dot. So understanding range is a big deal. Now, here's how it affects the graph. If we go ahead and look at it, this is Dan's time. Again, my domain are all positive values. Plotting points here. My range are my y's. They went by 20s. I would have probably gone by 35 since that was the slope. And then here's Kim's. What's different? Hers starts at 40 instead of at 0. So comparing. They have the same slope, but different y-intercepts because they started at different points. So it talks about comparing properties of linear functions. So again, you can read through this. The year term problem here. Find the rate of change for the linear function that is shown in the table. Okay, what's rate of change? Rate of change is nothing more than our slope. So it's asking here, what is the slope here? So how do you get slope? Change in y over change in x. So what's my change in y? Here it's going up 7. What's my change in x? Going up 1. So what is my slope? My slope is 7. Now they use the formula here. You can do whatever you want to do. For this one, the rule for f of x in example 1b is f of x equals 6x. If the domains were extended to all real numbers, how would the slopes and y-intercepts of f of x and g of x equal to 5x plus 11 compare? Well, so initially, and this is where you want to look at a graph, initially that one's going to be more. Why? Because it started at 11. But if you extend on forever, eventually this one's going to get bigger than this one. Why? Because it has a bigger slope, therefore it's steeper. So even though the 6x starts here at 0 and does like this, and the 5x starts at 11, it's going flatter. So whenever they cross here, the point of intersection is when they're the same. Up until that point, the 5x plus 11 is bigger. Why? Because it started higher. But eventually, the 6x is going to take over because it's got a steeper slope. And those are kind of the things you want to understand with comparison. So here's another example of a word problem. Again, you can look through this one on your own. And one that you can fill in. So since this is a video, you can look at the values and hopefully help right to the your turn. And again, evaluate this one. So it says an experiment compares the heights of two plants over time. A plant was 5 centimeters tall at the beginning of the experiment and grew 0.3 centimeters each day. The function f of t represents the height of the plant in centimeters after t days. The graph shows the height of the second plant, g of t, in centimeters as a function of time, t, in days. Find the rate of change of g of t and compare it to the rate of change of f of t. So what's it wanting you to do? Well, you know f of t, the slope is 0.3, and it started at 5 centimeters, so that's the function. What it's asking you to do is find the slope of g of t. How do I do that? All I do is I use the points. What happened to the y? I went down 4. What happened to the x? I went down 16. So what do? You do -4 over -16, and if you do that, you get 0.25. So the slope of g of t here is 0.25. What's that mean? Its slope is less than f of t, which means what? F of t is growing faster. So all of this is just being able to read and understand, compare different functions based on different information. So what are you doing? You will be doing on page 287, not 286, but page 287, numbers 1 through 25 odd.